The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is a 40-year-long study has led astronomers to conclude that there's something seriously weird about Jupiter. The largest planet in the solar system doesn't seem to have seasons. The measurements have been taken both by spacecraft and ground-based telescopes. They showed bizarre weather patterns on the gas giant. For example, cold and hot periods throughout the year, which equal 12 Earth years. And at the same time, Jupiter doesn't go through seasonal changes like our planet. On Earth, weather changes between winter, spring, summer, and fall because of the tilt of our planet's axis toward the plane in which it orbits the Sun. This tilt, which is 23 degrees, allows different parts of the globe to receive different amounts of sunlight throughout the year. But Jupiter's axis is tilted toward its orbital plane by a mere 3 degrees. It means that the amount of sunlight that reaches different parts of the planet's surface throughout its long year hardly changes. But the new study has found that there are still certain temperature swings that take place all over the gas giant's cloud-covered globe. Astronomers claim they've solved one part of this puzzle. They've found some hints that such unseasonal seasons might have something to do with teleconnection. This phenomenon describes periodic atmospheric changes in seemingly unconnected parts of the globe, which can lie thousands of miles apart. Scientists have observed teleconnection in the atmosphere of our planet too. One of the most famous examples is known as the Southern Oscillation. That's when changes in the trade winds of the western Pacific Ocean correspond with changes in rainfall across large territories of North America. As for Jupiter, when temperatures rise in specific regions of the planet's northern hemisphere, the same latitudes in the southern hemisphere cool off. Further research also revealed that when temperatures rise in the upper layer of Jupiter's atmosphere, called the stratosphere, it gets colder in the troposphere. This is the lowest atmospheric layer where weather events, such as Jupiter's powerful storms, occur. Researchers hope that by measuring all these temperature changes, they will eventually be able to make a more or less precise weather forecast for Jupiter. Maybe in the future, they will even be able to extend this to other gas giants to see if they have similar patterns. But this isn't the only mystery the gas giant can boast. Let's have a look at some other, no less intriguing puzzles. For example, a 2018 study that found that Jupiter had a delayed growth spurt. You might have heard that the most popular theory about the beginning of the solar system says that, at first, the Sun was orbited by a dust-filled gas cloud. Some time passed, and tiny pieces gathered together into lumps, which later formed planets. But Jupiter was the odd kid. It started off well. The gas giant was gathering around small clumps of matter for 1 million years or so. But once it grew to be as massive as 20 Earths, its development suddenly stopped. It could have happened after bizarre zones appeared in space. They emitted so much heat and energy that gas molecules struggled to merge with young Jupiter. This period continued for 2 million years. During this time, Jupiter only grew to 50 times the mass of Earth. But once this stage finished, the planet continued to gobble down gas like before, and soon it swelled to its current mass, about 300 Earths. Jupiter's most famous feature is the Great Red Spot, a giant storm raging in the atmosphere of the planet and capable of engulfing 2 Earths. But few people know about the Great Cold Spot. It was spotted only recently when astronomers were checking data received by an observatory in Chile. It's believed that Jupiter's auroras spawn this unusual patch, which is around 400 degrees Fahrenheit colder than the surrounding areas. These auroras are ancient. It makes the spot thousands of years old. And unlike the Great Red Spot, it's not stable. It keeps shape-shifting, and sometimes it almost disappears. But it always returns to the upper atmosphere. Usually it happens after a powerful auroral display. Now, storms are no stranger to Jupiter's atmosphere. But where there are storms, there is lightning, right? Yeah, but the bolts of lightning on Jupiter turned out to be very strange. They release radio waves, which is not strange, but for decades, every spacecraft visiting the gas giant managed to record something bizarre. You see, Jupiter's lightning only signaled in the low-frequency range, and no theory could explain why, since lightning on Earth emits radio waves from low to very high frequencies. Finally, in 2018, the Juno space probe solved this mystery. Apparently, the problem was not with the gas giant, but with our technologies. Unlike previous spaceships, Juno had extremely sensitive equipment, and it came very close to Jupiter, so it did record both megahertz and even gigahertz strikes. But even Juno confirmed that lightning on Jupiter was totally different from lightning on Earth. On our planet, lightning avoids the poles. It prefers to zap the equator. Meanwhile, the gas giant's equatorial zone sees no lightning. It lights up the planet's poles, and its peak frequency is 4 bolts per second. In 2017, when astronomers were searching for the theoretical Planet X, they noticed that some object outside the solar system was tugging at objects within. Thinking it could be what they had been looking for, they turned a powerful telescope in that direction. Coincidentally, that patch of sky contained Jupiter. And even though the researchers didn't find Planet X, they noticed 10 previously unknown moons orbiting the gas giant. This brought the number of the planet's satellite to a total of 79. But the coolest thing was that one of the newly discovered moons was very unusual. The thing is, Jupiter's moons move in packs, so 2 of the new satellites were spinning with a group that rotated in the same direction as the gas giant, and the rest was in a cluster spinning against the planet's rotation. As for our weird guy, it was inside the second group but spinning with Jupiter. Unfortunately, it means that the moon will most likely have a short lifespan. An anti-retrograde moon within a retrograde cluster won't be able to avoid a collision. Look at Jupiter's beautiful patterns. Look at these swirls and stripes. For a long time, no one knew the depths of these bands. But in 2018, scientists used a novel way to crack this riddle. This method involved the space probe Juno, which orbited the gas giant every 53 days. Each time it passed by, it measured how strong the pull of the planet's gravity was. It helped astronomers create a 3D image of the stripes. It goes like this. The greater the pull, the greater the mass of the region below. And after examining the gravitational map, Researchers concluded that the stripes ran shockingly deep. Most of them plunged to a depth of 1,800 miles. But Jupiter is a gas world, and the winds raging in its atmosphere shift all that mass around, making calculations very difficult. Jupiter has the strongest magnetic field of all the planets in the solar system. It's 20,000 times more powerful than that of Earth. But the gas giant's magnetosphere is a bit wacky. It's unique and doesn't resemble the field of any other planet we know about. Before, experts thought that Jupiter's magnetic field was similar to Earth's, two poles connected with magnetic lines near the geographical north and south. But Juno showed that things on Jupiter are a bit messed up. The magnetic South Pole is pretty well behaved, but the North Pole is a different story. Intensely magnetic ribbons and chaotic pieces of field, some of them without even positive or negative counterparts. Plus, there seems to be another South Pole. It might be that Jupiter's hydrogen ocean generates the magnetic field of the planet. And if scientists manage to solve the mystery of Jupiter's magnetosphere, they might also find out what's happening inside the gas giant. But first, they need to understand the bizarre behavior of the planet's poles. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh?
Jupiter has 79 known moons, and the four biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42 and a half hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. Water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
When you explode planets, things get red hot. Atmospheres are pulled away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. But how can you do it? How can you blow up, let's say, Jupiter, the largest planet in our solar system? Thick brown, yellow, red, and white clouds hide its surface, making the planet look colorful and beautifully striped. First of all, we shouldn't forget that the gas giant's powerful gravity is holding it together, which is the reason for the planet's spherical shape. And we would need to add a lot of energy to blow it apart. But here's the problem. If we used some explosive material for our goal, it wouldn't be very efficient. A lot of energy would get radiated as heat in the process. The mass of Jupiter equals 318 Earth's masses and about 1,000th of the mass of the Sun. The gas giant's diameter is also more than 11 times greater than that of Earth. It would be around 1/4 of the distance from Earth to the Moon. So, can you imagine the enormous binding energy that keeps Jupiter together? Now, experts claim that to explode this space giant, you'd need a pile of nuclear explosives as heavy as 4 moons. Can you imagine it? Or let's take another unit. A highly explosive material known as TNT. How much of it would you need to blow up Jupiter? The answer is 50 megatons. And 1 megaton is 1,000,000 tons of TNT. These are some huge numbers. They also mean that if you made Jupiter out of TNT and blew it up, the explosion wouldn't produce enough energy to blow the planet itself apart. It would puff up more and more. But gravity would still manage to pull all the stuff Jupiter is made of back together. But let's suppose you somehow managed to find an enormous amount of explosives that would be enough to get rid of Jupiter. You hit the button, sitting in your spacecraft, hovering over the giant planet. Something is going on down there on Jupiter, but it's unlike anything that would happen to a rocky planet. Instead of chunks of solid crust, you see jet streams of gas accelerating away from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away into space turns liquid. That's hydrogen in its different form. Under immense atmospheric pressure, this gas becomes liquid closer to the center of the planet. A bit later, you notice that the liquid becomes different again. Now, it's a mixture of metallic hydrogen and helium. And finally, something solid. It might be Jupiter's core, which is 14 to 18 times the mass of Earth. The blast lasts no more than half a second. And still, the explosion is millions of times brighter than the sunshine. It's so powerful, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. How would the disappearance of Jupiter affect our solar system? For one thing, this gas giant shepherds the asteroid belt. And without Jupiter out there, the belt might grow unstable. It would lead to an increase in the amount of debris invading the inner solar system. Plus, the gas giant also acts as a sponge, absorbing rogue chunks of rock and not letting them enter the inner solar system. So, it's great that Jupiter is practically indestructible, unless it collides with an object as huge as the Sun, of course. Or you could probably scoop the planet up a bit at a time. It would certainly take a while. One hypothetical project called a Jupiter brain suggests taking Jupiter apart and turning it into a planet-sized supercomputer. And you know what? Some advanced technological civilization could probably do it, but not us humans yet.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy materials settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. this kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and materials circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star, if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.
Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust and colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth. It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The Red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the Red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere, with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker a long time ago. It created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked the different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern lights show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.